If you're lucky enough to be working on code bases with tests, surely you've heard of the mighty code coverage, and at some point even tried to get to 100% to
maximize the code quality.
In this video, we show that code coverage is a metric which does not represent how much or how well our code is tested, how to game it, and how to ungame the game. Hi, I'm Dado. I'm a professional developer and software consultant for 20 years, most of which is spent dealing with automated testing and code coverage. Stick around to find out more what mutation testing has to do with code coverage. This is Quick Pondering Rocks. Many developers and their managers mistakenly believe that code coverage is a percentage of code that has been properly tested. Unfortunately, this is not the case. Code coverage represents the percentage of code that has been executed during testing. This subtle distinction is a significant gap between what developers believe they are measuring and what they're actually measuring. In fact, misusing code coverage like this can lead to a false sense of security, where developers and their managers see magic number get bigger, red checkmarks becoming green, a greenwashing effect which you can put on a chart, show to stakeholders, but it doesn't actually represent the quality of your code base. And why is this happening? As the test is running, the test runner will take note of which lines of code are being executed in between the test start and the test ends. It will filter out obvious exceptions, like itself, but then report everything else as covered. This is the crux of the issue. Since covered means anything that ran during testing, we can game the metric by just executing any and all code during testing and then not checking the outcome. The code will get marked as covered, but we didn't actually test it, and used like this, code coverage is meaningless. Of course, in actual production it will not be as obvious, but it will have elements of this problem. Since coverage is saying which code is executed and not tested, how do we find out which code is tested? The solution is actually quite simple. Every test needs to declare exactly which code it expects to be testing. For example, if we're testing classes, a test will say, I'm testing class A, and when we run it, any code that is not class A should not get marked as covered. If any other code gets executed during execution of this test, the coverage is discarded. We're purposely trimming down coverage, which will drop the percentage. This makes the reported figure much more accurate, which allows us to rely on it. Wait a minute, doesn't simply marking everything as covered postpone the problem? Well, yes, but this allows us to double opt in the covered code for mutation testing. What this means is that the covered code, or the code which is marked as covered, is absolutely meant to be covered, and the tests should notice any issue in the code. How about we break our code ourselves on purpose? For example, adding a 1 where there's a 0, adding a 0 where there's a 1, adding a plus where there's a minus, you get the idea. If they now fail, it means they've noticed us messing with the code, and tests failing here is actually a good thing. We've confirmed that the code marked as covered is actually covered, and our code coverage reporting is much closer to reality. If tests do not fail, even though we just added an issue, it means that we found a piece of code which was marked as covered but wasn't. At this point, we either add more tests to match the coverage, or we tell the system the code is not supposed to be marked as covered. Either way, we win. This break code on purpose, rerun the test and see if they notice, is actually a technique called mutation testing. It's a way to test the tests themselves by automatically introducing small faults in your code, rerunning the tests, and then seeing if they notice, in which case tests failing is a good thing. Since we obviously don't want to be breaking our code manually, we should use one of the mutation testing frameworks available for our stack. If you're thinking,
this mutation thing is interesting,
which you should check out this video.